Hello, everyone, and welcome to the July 9th edition of the vBrownbag US podcast. We're continuing on with the Cisco certification track, and today we have Dan Barber. You can follow him at DanCBarber on Twitter. He's presenting Cisco CCNP Data Center and focusing specifically on UCS tonight. Okay, so again, you can find the entire show schedule over at professionalvmware.com. Also, our vBrownbag Junior program that's being run by Jeremiah Dooley is in full swing, so please continue to reach out to Jeremiah if you have any ideas on how we can get our youngsters involved and introduced into technology in a fun way. So the two ways you can do that is to message with a hashtag vBrownbagJunior, or you can tweet Jeremiah directly at his Twitter handle. Now, if you want to talk to specific vBrownbag podcasts or to all of them, we have all of our Twitter accounts listed right there. And we also can follow along with the conversation tonight with the vBrownbag hashtag. So I'll be monitoring the chat window, or the question window, sorry, and the Twitter hashtag online on Twitter as Dan is talking, so we can have our questions answered in real time. Now, if you're interested in other geographical regions for other bag podcasts, we have the Asia Pacific that happens every other Thursday at 9 p.m. New Zealand Standard Time. We have EMEA happening Tuesdays at 7 p.m. Greenwich Mean Time. We have Latin America, that's Thursday, 7 p.m. Pacific Time. And the U.S. Brown Bag, which you're listening to right now, is every Wednesday at 7:30 p.m. Central. So Dan, if you are ready, we'll go ahead and turn over presenter duties to you.
Sounds good.
Okay, let me go ahead and make you the presenter. Okay, you should be good to go.
All right, everybody can see that?
Yeah, we're seeing
now?
the presenter, yes, the presentation.
All right. Good. Well, thanks for tuning in this week. I'm excited to be with you. And we're going to do a brief look at the Cisco CCNP DC certification, and you're going to find out why it's a little bit more brief than the CCNA that Tom talked about the last couple of weeks. Tom's actually going to pick up next week as well, and I'll tell you about that. So just a little bit about me. I'm a solution architect in Indianapolis, and I've been in IT for a while, customer facing, especially for the last 5 years. And there's my blog. And, full disclosure, I do love NetApp, so if you read my blog, you'll see a little pro NetApp-ness on there, and VMware vExpert as well. So I've done a lot of work. I've been working with ESX since ESX1, so a lot of fun in VMware. And tonight, though, we're talking about Cisco UCS and the CCNP. And the CCNP is a group of 6 tests that you have to complete, at least 2 of one section, and then another optional 2 focusing either on design or on troubleshooting in those respective areas. But they're really 2 main components: unified computing and unified fabric. And as I talked with Tom about it, the best way that we felt to be able to break this up was to spend the first week talking about unified computing, and to spend the next week talk about unified fabric, because it's hard to switch back and forth between the two. It'll be easier for you guys as well as us. In fact, some people even take the tests that way instead of taking them in the block where you do, unified computing and implementing unified computing and implementing unified fabric. Instead of taking those together, some people will take all the unified computing exams that they want to take. So they might take 999, which you have to take, and then also 998, or 035. I don't know why it's 035, by the way. You might find that amusing. I find it amusing that that's the number. So, but that's just an idea. You don't have to take them necessarily in any particular order. So, and you can find a good resource, as I've noted at the bottom there, is Cisco Live, if you've never been. I actually have never been, but I've watched a lot of it online. I hope to be able to go next year. And you just need to create an account. And here's a list of some other resources that are really good for you as you're studying. The Interactive Design Zone is good for all things, whether it's UCS or it's Nexus. The Cisco Validated Designs, you'll hear a lot about that. If you're not already working in customer-facing roles, Cisco Validated Designs are pre-configured. You know, this firmware level matches this firmware level, matches this configuration with this revision, etc. Well-tested designs. The exam blueprints, of course, and Cisco UCS Emulator. The emulator, if we get done early, we'll take a look at it. The emulator is a free download, and you can actually build out a virtual UCS environment that is pretty functional. I mean, of course, it's all simulated, but I mean, you can do a lot of stuff with it. Now, there's certain things you can't do for obvious reasons because it's a simulator, but it really gets you, if you haven't used UCS a lot and you don't have the benefit of having a lab or something that you can play around with, the emulator will really get you familiar with the interface. In the introduction to Cisco UCSM service profiles, which is kind of the heart of UCS, and even an interactive model that shows you the hardware, because a lot of us don't have all the hardware pieces. But you need to be familiar with all the hardware pieces. And of course, Cisco Live.com. So those are some resources for you. You know, like any other test, hands-on is better, but reading is definitely required because none of us are going to be doing every possible thing that's on the exam blueprint. And so you just got to kind of focus on those areas that you feel like you're maybe a little bit weaker in, and read up on those, you know, as best you can. So that's just, you know, a little test-taking strategy. One of the things I like to tell people is to remember when you're going for a certification, you have to think like a test maker. And a lot of times, you know, I'd be working with people and they'd say, well, I know the stuff, you know, and I would agree with them. Yes, you know the stuff, but you didn't take the test well. You got to think like a test maker. And so we'll talk a little bit more about that as we go. So Cisco UCS Architecture, let's take a look at that. And, oops, hold on, let me go back. I'm trying to get rid of this GoToMeeting control panel here. It's in my way. There we go. Okay. So Cisco UCS, these are the main components of a UCS system. And I'm going to kind of breeze over some of these, you know, fairly quickly because you can go back and look at the slides if you want to reference them if you're, you know, a very new person to UCS. And I'll just kind of, I'm going to hit some of the more, you know, CCNP-ish type things with UCS. So, but I just want to provide them here as a resource. So there's your basic layers. Your I/O adapters are also called VICs, or virtual interface cards. Your blade and your rack server. So Cisco UCS is really unique in that you can actually manage your rack servers the same way you can your blades. And that's something a lot of people don't know. and you might look for questions like that on a test. The blade server chassis, of course, is what most people are familiar with. The chassis I/O module, we're going to talk a little bit about that because it's got some fun names. Fabric Interconnects, and then UCS M or UCS Manager. So let's talk about how the architecture works. One of the things that Cisco touts and is really an impressive feat in itself when you get down into the nuts and bolts of it is single wire connect. You can run in this chassis right here on the left, you can run an entire chassis of 8 blades off this one cable if you wanted to, and still have high availability and 10 gig throughput. And that's a pretty awesome thing about UCS. And one of the things that Cisco tells you is to design not for the traditional connectivity options. I want 2 here, 2 there, 2 here, 2 there, 4, 6, 8, but really based on the bandwidth needs of the chassis. And with every wire running at full 10 gig, in a lot of cases, you really only need to cable up 2. So, in fact, I would say most of my customers, because the Fabric Interconnects are licensed based on port count, I would say most of my customers stick to the 2 per chassis. I don't really find many are doing 1, though you can. And I find some doing 4. I don't really know anybody that does 8. But again, I'm sure that there are plenty of people that are doing that. It is active, and we'll talk a little bit about that here in just a minute. So if you want to look a little bit more at kind of a little bit of a logical view, we'll look at a couple of different slides here just so you can kind of see where things fit together. Because that's one of when you talk about Cisco and it talks about abstraction, the word abstraction, what they mean is they're separating the hardware, right, from its feature set so that you can manipulate it. So a physical PCI adapter can now become many virtual PCI adapters and so forth. And so sometimes with UCS, when I'm sitting down with customers and I'm walking them through it and they're not familiar with it, you have to kind of get a picture and say, all right, let's look at where everything fits together. So even in this one, you have some B-series chassis. You could easily have rack servers in there as well, as it notes, and there's even a rack server here. And in this case, the rack server is connected to a Fabric extender, a 2200 series, via 10 gig, which then is connected back to the Fabric Interconnects. And this is kind of the way that it works. All of your management for all of these devices, everything underneath the Fabric Interconnects is all done at the Fabric Interconnect level. It's a single point of management, which is really awesome. If you've ever worked in multi-rack server, multi-chassis environments, you know which chassis is this on. Okay, I got to log into this chassis. Which chassis is that on? I thought it was on this chassis. Well, no, it's on this chassis, so now I got to go look at that. That's all, out of the way. So when you look within the chassis, we'll look at a couple different slides here. This shows, say, a half blade, which I would say, again, most people use half blades versus a full slot blade. You'll notice that each adapter has connections to both sides of the chassis. And you'll notice that they call this part right here the fabric extender. So let me say a little bit about that. Cisco uses the term FEX, or fabric extender, pretty loosely. They actually use it to refer to multiple pieces. For the best way to think about it, it's really a category. A FEX is not just one piece. It's really a category of pieces. And it's any piece that extends the function of a fabric, okay? Whether that piece is physical, as in the case of an I/O module, or whether that piece is virtual, as in the case of like a virtual NIC for VMFX, which we'll talk about. So anything that extends the fabric, that's how I remember it, is categorized by Cisco as a FEX. And so when you see fabric extender, don't automatically think, like some people do, a 2200 series, because Cisco might not be talking about that. Okay? But you'll notice that even with a single adapter and a half, half slot blade or half width blade, you do have redundant connections to both sides of the fabric, so you don't have to worry about that. You don't need a second one for redundancy. You really only need a second one for bandwidth, if that's what you're doing. And again, multiple active-active. And if that was not clear enough, this one can be even more clear. So in this case, here's a B200, which is a half-width blade, one converged network adapter, and each converged network adapter has 2 ports. And in this case, so one side comes out IOM or FEX A up to Fabric Interconnect A, and from here can traverse, to the core on the left or the right, depending on how you have it set up. Same thing with Fabric B. It's active-active, so you can continue to go both paths simultaneously without worry, and that applies to rack servers as well. This could easily be, either one of these could easily be a rack server with 1 or 2 virtual interface cards in it, and it would logically function the same way. And so you cable up your C200, C240, C260, and you just cable 2 10-gig ports to a Fabric extender, a 2232, and that's your whole system. It's your management plane, it's your data plane, it's everything, and that makes it really slick. So, and one more little thing I want to show you about the internal guts. This is looking at the VIC, the Virtual Interface Card 1280, but it applies to all the virtual interface cards, and that is that whether you have a 1240, which is just 40 gigs out, 2 and 2, 2 on each side of the fabric, it's hardware port channeled inside the chassis. So you have hardware port channeling between the VIC and the 2208, as it says right here. All right. And that just gives you, it's doing automatic load balancing, it's doing the whole thing together. It's a really efficient system. And that's something that you'll want to keep an eye out. And of course, your 22.8's going up to your Fabric Interconnects. These are also dependent, in the slide here it says that they use another channel configuration, but they can be configured as independent links or as a port channel.
All right, so
what?
I'm sorry, Dan, I have a question. Now, this question is coming from Graham about needing licenses for FCoE and FC for the SAN interconnects. I'm not sure of an additional license being required aside for the Fabric Interconnect port licenses, which a bundle of licenses does come with your Fabric Interconnect purchase, right? So
that's right. So
there's no special license for FCoE and FC. Am I correct?
No, there's not. And Graham, we can. I'll talk about that a little bit on the Fabric Interconnects when I talk about FC, how to create FC ports. But the easiest way to think about licensing on the Fabric Interconnects is it's licensed really for port enablement. Every port is unified, so every port can be fiber or Ethernet, can be an uplink or server or whatever. And there's a couple of caveats that I'll share with you about that. But you're really enabling a port. So with the 6248 UPs, you get 8 ports. I'm sorry, you get 12 ports. And with the 6296s, you get 16 ports. So that's ports that are downstream from the Fabric Interconnect to your IOMs, okay? And it's also ports that are upstream. If I go back here, so yes, if you were buying a native fiber channel module like you have here in the extender, or in the Fabric Interconnect, you would just buy that module, and that module would come with additional port enablements, but it's not specific to the module, if that makes sense. In fact, we've even had people who buy modules just because they'll get the port licenses, because the module is for some reason on sale, and it was cheaper to buy the module than it was to buy the expansion license, if that makes sense. So in this case, these guys right here would come with 16 ports enabled, and those 16 can be really anywhere on the switch. Okay, so that's what you're licensing. Go back. All right. So that's kind of where we are. All right, so let's talk a couple more things about architecture, and then we'll go into some a little bit more specifics on connecting and configuring. There are two main operating modes, and you'll get, you would expect that you would find, if you look at the exam blueprints and the breakdowns, you'll find a lot of percentages weighted on configuration, the difference between these modes, etc. So the predominant mode is end-host mode. That's what you'll hear it called. And in-host mode is basically, from a server perspective or a chassis perspective, the Fabric Interconnect right here looks like a switch. But to the network, northbound, it looks like just a bunch of hosts. And so it's really, really slick in the way that it does that. There's no spanning tree issues at all. In fact, spanning tree isn't even possible, because the Fabric Interconnect only learns MAC addresses that sit southbound. So you'll notice there's a little logical division right here. Any MAC address that is not known by the Fabric Interconnect, that will automatically get forwarded northbound out the uplinks. Anything that is known automatically gets put back down to where it is. So it's a really efficient system, and you never have to worry about spanning tree. It's full active-active on all paths, which gives you really good performance. The other mode is switch mode. And switch mode is what you would expect it would be. It is where the Fabric Interconnects actually function as a layer 2 switch. And the use case for this is really when you're putting the chassis or the Fabric Interconnects right up next to some routers, and you're working with disjoint layer 2 networks like a DMZ, or you have some other kind of thing where you want to do one network in, one network out, for example, as you can see here. And I would say, in my experience, probably, I don't know, 80 to 90% of the time that I see this, which is not very often, by the way, it's for a DMZ application. So it does have spanning tree. It does have VPCs. It will not do VTP in any mode. And it doesn't have the full feature set of a layer 2 switch, even though it has Nexus OS on it. It doesn't have the same feature set. But that's kind of the use case. That's what you need to know about it. And you can read more about that, in the resources that I provided. So that's pretty good. And you can use, in this example, I would say this is a good use case for taking your FEXs or your IOMs um, and doing what's called MAC pinning, and pinning certain VLANs, certain MAC addresses, etc., out certain uplinks so that you get full, even physical isolation as well. It is possible, even though this is converged infrastructure, it's still possible to create a physically separate infrastructure if that's in fact a business requirement. So you need to know that. Um, Likewise, on the storage side, you have the same thing where you have an in-host fabric mode and a switch mode, a fabric switching mode. And they function very similarly in that if you go to FC switch mode on the Fabric Interconnect, then you have access to zoning straight on the Fabric Interconnect. You don't need a separate switch. Now, again, you want to make sure that you understand the use cases for that. And again, I would say typically people don't do that. They would more go in and create an appliance port or a SAN port, which I'll show you, and attach the storage directly in that case. But that's really the use case for that. So when you do that, you trunk. These ports up here become TE ports in fiber channel terms, which is a trunking E port. So as opposed to an MPV port. If you use in-host mode, you have to have an MPIV capable switch on the northbound side, okay? Whether you're doing FCoE or FC, it's got to be MPV capable.
Right. So one thing that may trip up people is that they think that MPIV may require a reboot. If you're using Cisco MDS switches, you don't need to reboot to enable MPIV. Reboots only are required if you're enabling NPV. It's very, very important that you distinguish between the two.
Absolutely. Absolutely. Yeah, no, it's just feature MPIV and boom, you're ready to go. And in reality, I mean, Cisco, if you're connecting to a non-Cisco environment, for example, like in a Brocade, oftentimes those switches, my experience, have come with MPV ready out of the box. So I'm not sure about other manufacturers, but that's something you can investigate. We're not talking about that today. So last thing on this one, in terms of architecture, is just an example because multi-tenancy is a hot topic. So remember that I said when you're taking a test, you want to make sure that you're thinking like a test maker. And test makers love to test about new features, improvements, especially if they are considered competitive differentiators. So something, like this, that's which Cisco says this is our multi-tenancy, the way we would do multi-tenancy in a fabric scenario, for example. You want to read a little bit about, how do I configure for multi-tenancy in a unified converged system that's all traveling the same, traversing the same physical uplinks, or maybe it's not traversing the same physical uplinks. So even in this case, you can see here is a UCS VN tag, and a VN tag is their implementation of a particular IETF standard, and it's just a way to identify what vSANs and everything is actually being passed along the same cable, and that's how you can get your multi-tenancy separation and isolation, but still use the same physical medium, if that makes sense. In this case, in something that you should know when it comes to FCoE, is that FCoE MAC addresses are generated by the Fabric Interconnects. You don't configure those yourselves. You provide the FCoE VLAN, you enable FCoE, go through the proper configuration means, but the Fabric Interconnects will generate the FCoE MAC addresses and give them the appropriate VN tags that correspond to their vSAN. So, any questions about that? I'll just give a second.
Yeah, there's one question from Graham about which particular standard is being supported, and he's asking about 1QBH. I do not believe we are necessarily supporting 1QBH, but it is very similar to that. Is that correct,
Okay.
Dan?
I
Okay.
think that's right, and I will have to look, but I want to say, if I remember the documentation correctly, it's Cisco's implementation of that standard.
Right.
So
And
it's
from what I
not
remember,
that implementation of the standard.
right, and from what I remember, Graham, about reading about that, is that the customizations that Cisco made for their implementation of VNTag has been submitted to the appropriate standards bodies for acceptance as a protocol as well.
Yeah, I believe an analogy would be to say um, either channel is an implementation of a global standard, like say LACP, even though LACP came after either channel, but that's an equivalent analogy to the way that VNTag is. So it's not
Sure.
the standard itself, I don't believe.
Understood. And Graham mentioned that he's concerned about working with proprietary standards. For example, he uses LACP rather than PAGP. I think the whole world does as well,
Right,
and
right,
OSPF rather than EIGRP. Now,
right.
just want to put this out here. When you're working with UCS, you're not necessarily going to be swapping in HP blades just because connectors and things like that are specific to Cisco hardware. But that being said, once you have the hardware, any workload that you can run on x86 can run on UCS. So
That's
you're not
right.
really concerned about, proprietary standards or anything that are going to prevent you from getting the most out of your workloads.
No, that's right. And really, in this, the reason I think that it's proprietary is because Cisco needed it to do something in the chassis that the standard didn't provide. Now, I don't know the technical details of what that is. That's just my suspicion, because that's usually what Cisco does: is say we need to be able to do X, and nobody's doing X, so we're going to make it. And so, uh, that's my best estimation on that.
Right.
So, all right, let's press on, and we'll talk about connecting up, because that is part of the implementation, troubleshooting, etc. Components of the exams, I should say, and it's going to be only a couple of slides because that's part of Cisco strategy, right? Single wire connect. Little misleading. You do have a couple more wires you have to connect than one. The first thing is, how do you connect the Fabric interconnects together? And that's going to be, by the way, this is considered to be the rear of the Fabric interconnect. If you've never seen it, it's rear facing, meaning all the ports are in the back of the rack, and that really throws people for some reason. Just the same way that Nexus usually sits there as well. And that's really just because the I/O modules are also sitting back here, and it just makes cabling it really easy. So to put the Fabric interconnects together in a high availability pair, you just put L1 to L1, L2 to L2 in the back, and that's it. They're redundant links. They are management plane only. Okay? and it's active standby. So when you look in some screenshots of UCSM, you'll see Fabric Interconnect A primary, Fabric Interconnect B subordinate, or vice versa. Depending on whether or not you've had an event and you've switched over or whatever. But the data plane, all of your data traffic across those Fabric Interconnects is active. Okay? So don't think about this as like a VPC peer link or anything like that, because it's not. And it's not really a keep alive either. It's more like a stack, an old stacking implementation. It's really just for management only. So that's the first cables that you need to connect. And then the second ones are your IOMs or your FEXs, as Cisco sometimes calls them. So what you want to do is the one on the left, and you don't want to do the one on the right. And the reason is because of the ASICs. So Cisco, loves ASICs. They do a lot of things that are ASIC based, right? In UCS, it's not good enough to call them an ASIC, so we're going to call them a unified processing core. I think is what it is. So it's
I'm learning new things every day. I didn't even know that was the proper terminology.
It's an ASIC. I don't know what the deal is, but it just cracks me up. But you want to make sure that when you're cabling a single IOM, that all of the cables to that IOM go into a single ASIC. And the reason for that is because ASICs are independent, okay? And if you were to do the scenario on the right, you would only be able to create one virtual interface because it would span two ASICs. And you want more than one virtual interface northbound. So it's a limitation of the way the ASICs are. And I won't go into all the details about that. So just remember, if you're presented with a question, what's the proper way to cable something, you just want to remember, hey, let's look at my ASICs. It doesn't matter if I put it in 1 and 2, 3 and 4, or if I put it in 5, 6, 7, 8. That doesn't matter, right? And so some people, you'll see all kinds of cabling schemes, whatever's right for you guys and for your customers. Actually wanted to talk about this a little bit later. So I'm gonna skip the content here and bring it back up in just a second. The other thing that you're going to want to be familiar with is the various partner ecosystems. So FlexPod, VCE, vBlock, etc. And how those might look in an implementation, because one of the things that Cisco UCS has done really well is its validated designs and its reference architecture. And when you have that, this is a full FlexPod deployment guide, step by step, with a checklist that I put in this link here. It's all done for you, and that's one of the powerful benefits that you get to it for connecting to whatever backend architecture you want. And so just knowing, should I do virtual port channels northbound to my Nexus or to my 6500s? These switches are kind of interchangeable at this level, as is the storage on the back end. But I might want to look at how is it recommended that I configure the storage. Should I do whatever my vendor's version of port channeling is here, as well as at the core level or the aggregation level, whichever you want to put it at, etc. So just know how the components fit together outside of the UCS environment as well, because that's something that they really promote, and that's something that I would think you'd likely be tested on. And I would say one other thing about that is FCoE. So a lot of, even in my experience, a lot of customers, and part of this is because of the validated designs, a lot of the validated designs are FCoE boot from SAN. Because ultimately it's cheaper not to buy the hard drives, you have the SAN anyway. And a boot run takes almost no IOPS, and it's pretty easy to do when you have the kind of management that Cisco UCS has. So just know that, and we'll move on to kind of the heart of the system, which is configuring unified computing. So this is a little look at how the software abstraction works, and I can't remember who at Cisco put this together, but I'm very thankful for it because I'm a visual learner, and it really helped me to see how the different categories of abstraction fit together. So,
Dan, I'm sorry, before you continue on with the service profiles, one more question about the storage protocols. Graham is wondering if people are really running FCoE native disk arrays. From what he's seen, people are either using iSCSI or FC. So have any of your customers expressed interest in running the FCoE native arrays that are coming out of VMC and NetApp and all the others?
Actually, yeah, because in NetApp, for example, a lot of people are moving to unified ports the way Cisco has. And so if you bought, for example, today a 2252 or a 2552 NetApp array, it would come with 4 unified ports per controller pair. And so they do FCoE to get 10 gig as opposed to FC at 8 gig.
Interesting.
And typically, you know, I don't know anybody. And Trevor, correct me if I'm wrong, but I'm trying to think of anybody who distinguishes between an FC license and an FCoE license. If you get an FC license, FCoE is included and vice versa.
Are you talking about Cisco switches?
I'm talking about just anything. I've never come across anybody who distinguishes between the two implementations of the same protocol when it comes to licensing.
Right, I have not, but most of my experience is on the Cisco equipment side. Yeah. So of course we're not distinguishing.
Talking about Cisco, and Cisco, you know, Cisco obviously does. So you buy an FC license on a Nexus, and you can do FCoE, right?
Right.
So yeah, so it's really about the pipe. The pipe is 10 gig. Why limit it to 8?
Right. So maybe talk to your vendor, talk to your partner to make sure that that's the case as well too.
Very good disclaimer. So in as we talk about service profiles, so right here, you look at this little arrow, this subliminal arrow here. This is kind of the target is your server profile, okay? And this is all of the components that go into your server profile. So Cisco UCS is heavy on the creation up front, light on the application of it on the back end. I actually think that's a strength. It doesn't actually take as long as you would think to configure all this stuff, because a lot of these, especially policies, tend to be fairly global, as well as, say, something like UUID pools can be global, server pools, etc. And so it doesn't have to be as big an ordeal as some people make it out to be. But it is, you know, a number of steps, and we'll walk through and see what those steps look like. But the idea in terms of best practice typically is to create a service profile template, okay, for whatever that is. Maybe that's a finance department. And then apply that template to any number of blades. And the idea being, if you need to provision another server and apply a template to it, you can do that. Or take a server away from one department because another department is experiencing high volume of computing demand, and reassign a template to that, a service profile to that blade. You can move it around dynamically, and all it is the time it takes to reassociate with the blade. So it's very slick, very flexible computing. And if you haven't seen it, this is UCSM, UCS Manager. Visually, I think it's really well thought out because you got right up here at the top, and these are navigable links. You can click on them. And so you have my critical errors, you know, my severe, my information or my warning, and my informational, right? And then your 5 main areas of your tab, your equipment, which is your physical configuration, your servers, which is your service profiles, policies, most of your policies. LAN is everything LAN related, SAN everything SAN related. VM is integration with a VMFX, as well as vCenter integration. And admin, which is all the things that you might expect admin to be. For example, actually, I'm going to talk. I'll go over admin in just a second. So, a couple of places that people, in my experience, have had trouble finding between those 5. So, if you're looking on these 5, you'd think, where's my power policy? And how do I tell my chassis where to connect? You might think, oh, I click on my chassis and I tell it how to connect. Well, not so much. You actually stay at the top level and you come over to policies, and then you've got all these kind of overarching policies that apply to kind of the whole UCS domain. The couple of ones that you're going to want to know for sure, because these affect every UCS environment, is chassis and FX discovery. This is global. You cannot have one chassis as a port channel and another chassis as independent links. You have to have separate Fabric interconnects to be able to do that. So this is a global policy, as the tab says. A scrub policy is something that's used when you decommission a blade. You can automatically have that blade scrubbed. It will wipe the hard drives, including the boot sector. It's a really nice feature if you need compliance functionality for that. And whether or not you want to auto-acknowledge a rack server when it's connected, and your power policy. So most people are N+1, which means you have one redundancy. You only choose grid if you actually have full separate power sources, not just separate PDUs, right? That's the only time you'd want to use grid. So, and again, we do not have time to go over everything possible here because there's just so many different things, and I really want to just encourage you. You can go and kind of thumb through some of the slides, some of the other areas, get the emulator, and kind of move through that. And this is the service profile template. And one of the nice things about the way UCSM works is that there's a couple of different ways to skin the cat. You can actually go through manually, not in this wizard, and create each individual piece that you need. Use this as kind of a reference and go back to networking, do my configs, go back to storage, do my configs, etc., and then come here and do it. But a lot of these things, like networking, I can create a VLAN on the fly in the service profile template wizard. I don't have to leave and go. So there's usually, if you will look for it, there's usually links to create related things as you move along through any wizard that is in the system, which is really nice. Because I've more than once, wanted to go through and provision a new VLAN. Oh, I forgot to create the VLAN. Well, that's okay. I can do it right there, right? Can't provision it if you haven't created it first. So, I talked about configuring FC ports earlier, and so again, this goes back to Graham's question. The Fabric Interconnect is really licensed on a port enablement basis because every port is capable of doing anything. Now, the caveats to that. To create a fiber channel port, a native FC port, I have to go into, let's see here if I have a picture of it. Look. Sorry. I don't have a picture of it. I thought I did. You have to go in, you click on the Fabric Interconnect, and I'll show you where that is a little bit later. I think it's a little bit later in the deck. And you click Configured Unified Ports, and then you have this little slider here. And if you're not looking for the slider, you won't find it. That's one thing I'm not happy about. You click the slider's on the right, and you click it and drag it over, and it selects in pairs of 2 ports to be converted to fiber channel ports. And you will notice down here at the bottom, it says right here, my previous port state was unconfigured. My new desired port state is FC uplink. Okay, that would say FCoE uplink if it meant that. That's not what we're doing here. This is to create a native fiber channel port. It has to be done from right to left. That is the only option. And to be honest with you, I'm not sure why. I'm sure somebody somewhere has the rationale for that, but it is done with the fixed module as one module, and then each module itself is separate. So if you have an expansion module, you can configure right to left on just this expansion module, which a lot of people do if they have the other expansion module. So that's how you configure FC ports. It does require an immediate reboot. Once you click the finish button, it will reboot the Fabric, that Fabric Interconnect. So if you're doing it live and you're adding in extra ports for some reason, make sure you do the subordinate first, let it reboot, then change its role to primary, and then repeat, as necessary. That way you have an in-service, you don't have downtime. You just have the loss of those paths.
So yeah, talking about this, one thing I've seen customers do is that they'll get an expansion module, at least one, just so that they can maybe put some or all the fiber channel expansion module. When you do that, only reboots the expansion module the entire machine. So that's one advantage for your expansion module Fabric Interconnects.
Are you hearing me okay, Graham? Because I was getting a little, I was getting some feedback there.
Okay, was that me, Graham, the problem?
Okay, I didn't really hear what you said, so sorry about that. It was just a lot of echoing.
Oh, okay. Can you hear me okay now?
No, something's changed.
Okay. I will go back on mute.
Okay, it could be me as well. So I'm not sure. I'm using my computer, so I'll just continue to go. I will just briefly mention sub-organizations. You can create any number of sub-organizations, which is really nice. Again, that multi-tenancy feature. You can actually restrict VLANs to particular sub-organizations, right? Which is a really good thing, as well as RBAC roles. Again, looking at those features and saying, yeah, I can create individual organizations with individual policies within UCS. It's also good if you're doing test and dev, for example, and you want to have one set of rights, one set of features, etc., in your production environment, right? Which is, in essence, a multi-tenancy scenario. Your LAN policies. So there's a couple of places where you have to enable your jumbo best effort, you will not get jumbo packets out the chassis. That's a big gotcha. You got to set it there to enable jumbo packets. It's not enabled by default. This says normal by default. If you are going to try and do multiple lossless, that is non-packet dropping configurable groups here, you will probably run into problems, as I have. And so I would say my practice, and I was trying to find the document on this, and I couldn't find it. It was a Cisco KB, was to only have one lossless user configured class of service here. You don't want to confuse lossless, the underlying technology, with your QoS settings that are configured here. If you are using the Nexus 1000V, or say any kind of multicast, or anything that is generating its own QoS settings within the VMs, then you need to create a QoS policy that says host control full. Okay, and what this host control is a little bit misleading. I'm not really sure what that means, why that's termed that, but what that means is I will allow the VM on this host to which this policy is applied, I will allow it to send out DSCP and cause tag packets, and I will trust that those classifications are the right classifications, and I will not apply my own. You want to make sure that you have that if you're using the Nexus 1000, or if you're doing, like, say, unified communications, or, again, anything else that you've already had your DSCP levels or classes applied at the VM level rather than applying them through UCSM.
Oh, Dan, can you hear me now?
Yeah, that's better.
Okay, cool. So just a quick time check. We're coming up to an hour on the broadcast, so if you can stay longer with us, we appreciate it. But I just wanted to make you aware in case you have a time crunch.
Yeah, I don't have plans, and I apologize. I was hoping to move a little bit faster. If you guys are okay, you can just continue to, whoever wants to stay on, I'll finish out. I've got about 15 more slides or so, and I'll just hang out, and keep going, and anybody who wants to can hang on, or you can pick up the recording at a later date, if that's all right.
Yeah, please go ahead and continue. Thanks.
All right. So let me come back to our failover question. So this is a look at adapter policies. I'm going to create a VNIC template where I'm going to assign this VNIC to an adapter, a Cisco VIC, or if I'm doing VMFX, which we'll talk about later on, or to both. You can actually do it for both. What VLANs I'm going to allow, and you'll notice right here, here's that Create VLAN button that I was talking about. And I said, hey, I forgot to create my VLAN. Well, you can do it right there. Your MTU, your QoS policy, all this other stuff that's here. But this little box right here, enable failover, okay? Out of the gate, it seems like you would want to do that, but that's kind of a gotcha. The enable failover, and this is kind of the rule, you only want to check that if you are putting out this policy to a host that doesn't already have its own failover capabilities. So if the hypervisor, for example, VMware, is already doing NIC teaming or is going to do NIC teaming, don't enable Fabric failover for that VNIC template. And the reason is because your Fabric failover will converge much faster than your northbound uplink will come up, and what's going to happen is your host is going to start sending data northbound, except the path isn't going to be working. And if you have anything in there, like, say, an Exchange DAG that's doing, DAG heart beating, your DAG's going to start failing over on you, and you're not going to be happy. So you don't want to use this. That it's not double failover doesn't make it better. It actually makes it worse if you want to think about it that way. Typically, because
double failover isn't double better.
You got that right.
Okay, all right.
Two fails don't make a success. I don't know. I can't come up with anything else.
Okay, before we move on, though, one question that I missed when I was, making everybody deaf with my loud noise. Graham is asking, does an FCoE have to be lossless?
Okay, so back on, oops, hold on. All right, so right here, you'll notice that these two boxes are grayed out. Your FCoE is already configured. When this says fiber channel, this actually means FCoE because this is an Ethernet configuration. And so if you're doing native FC, it's applying its native FC frame size. If you're doing FCoE, it's already set up for lossless by default, and you cannot modify that. So these two parts right here are not user configurable except for the weight, and then you can't configure the packet drop on it. So it's going to be lossless if you use it, no matter what. One other thing about your templates, most people are going to use updating templates, and the difference between an initial template and an updating template, and it is exactly what it says. An initial template, you create it. If you ever come back and make a change to it, it will not be applied to any existing service profiles that are based on this template. I'll be honest with you, I haven't really found any customers that really want that. Everybody wants to be able to come back in and make a change. They want to come back in and add a VLAN. Obviously, I want to make my change and have that update my template that's applied to all my service profiles. So just make sure, because this is not selected by default. Okay.
And there's a good reason it's not selected by default, right, Dan?
Yeah, I'm sure there is a good reason. I just don't know what it is.
Right. Well, usually when you're doing the updating templates, you want to also adjust your maintenance policy, because when you make a change, for the most part, most changes will want to trigger a reboot to apply the change. So use updating service profiles with care.
Yeah, and I'll show you. That's a great point. One thing to note is that the only thing I've really come up against, like the Fabric Interconnects where it says, hey, we're about to reboot this right now, is that particular FC thing, creating the FC ports. But with any changes like this that are going to require a reboot, it's going to put everything to a pending activities buffer. And it's going to allow you to schedule those items that need to be acknowledged, okay? And that's by default, unless you create a maintenance policy that says go ahead and apply it straight away, which most people don't do. But thanks, Trevor. That's a good reminder. Your vSANs and your SAN policies, again, this is where you would create your uplink port channels for fiber, FCoE port channels, etc. And the first time I went in here, even sometimes today, I come in here and I expand my vSANs and I say, I don't have any vSANs. And that's because when you create a vSAN, just like if you create a VLAN that's pinned to a particular Fabric Interconnect, it actually shows up underneath that Fabric Interconnect. It doesn't show up in this global group right here. I'm not really sure, how I like that, but that's something that happens. And then something that I do, if I'm given the choice when I'm creating my WWN and my WWPN pools, for my servers, I like to add an identifier in the address, like somewhere, like say either 00 right here or 00 right here, just with an A or a B that tells me which fabric that's on. So when I go into my Nexus switch and I do a show floggy or show FCNS database, if I see any WWPNs, they should all be the same with that 0A, or if I see something with a 0B, I know I've done something really wrong. And so you don't really get anything like that when you have straight hardware, right? Because you can't choose the WWPN, but here you can. So why not make it work for you? And then just like your VNix, you'll create a VHBA template. And that virtual HBA, again, will have the frame size is already set. That's appropriate for fiber channel HBAs. You'll notice that you can't choose it to be on both fabrics like you can for a VLAN, right? Because it has to be pinned to one or the other. Fiber channel and iSCSI traffic does not fail over. That's only a network option. So just like in most scenarios with fiber channel, not so much iSCSI because it's Ethernet based, but with fiber channel, usually your fiber channel switches northbound are separate fabrics anyway. And if you have to reboot those or you lose one, you just lose the corresponding number of paths. And that's the case here. So just know that. And creating your iSCSI boot parameters and your FCoE boot parameters. Remember I said that boot from SAN is something that we see a lot of customers doing. It's something that's made really easy by UCS, and so that's something that they consider a competitive differentiator. And so you want to look at how do you set up iSCSI boot with my IQNs? How do I set it up FCoE boot or FC boot and create those policies and apply them? And for those of you that are in multi-tenants that are customer facing, or even if you have multiple sites and you don't want to buy UCS Central, something that's really nice to do, or if you just want to do a little CYA action, is copy the XML out from any one area or from lots of areas, and that XML is the configuration file. You can export that. And you can import it back into another configuration you want to. In fact, you can export your XML from your live production environment and import it into the UCS emulator if you would like to. So let me pause just for anything that came up on that, Trevor.
Right. So there was a comment from Joe about the tips that you brought up about FC and iSCSI, that he actually used that concept with setting up a UCS environment with a customer for zoning.
Oh, great. Yeah, absolutely. It's just one of those things, like if you've been around fiber for a long time and zoning, you know what a pain it is when you don't have all your floggy sessions like you expect you be able to do. And this gives you actually one more way to make your troubleshooting a little bit easier on yourself. So let's talk about, just for a couple of slides, one of the main differentiators, because everybody's talking about network virtualization. I'm not talking about ACI or anything like that. I'm talking about network virtualization within UCS and their category of it. It's a major feature, and it's one of those things that my experience is giving people a little bit of frustration on the exams. And so remember I said the term FEX really is a category for Cisco. It's not just one thing. And the sooner you get that in your brain, the better it's going to be for you. And so this slide, this really helped me from Cisco Live to show me the different kinds of FEXs that are out there in Cisco terminology. And
yeah, this is a really great breakdown. Sorry to interrupt you, but
no.
it can be a really confusing topic when you hear multiple categories of technology. So even though they are all similar ideas, this is a really great breakdown to show you the differences.
Yeah, and it was a little bit harder for me too, because I found when I was reading blogs and other internet websites, you know, some people would use the term FEX for one thing and some people the other one. I thought they're not using that term right, when actually both terms are right. And so, you know, it is really a little bit confusing, but rack FEX is really something that Tom's going to talk about next week. We've already talked about chassis FEX, which is your IOM module. Adapter FEX and VM FEX, we'll talk about those just here briefly. And so adapter FEX is really, you might hear it called SRIOV, single root IO virtualization. But it's basically taking the physical adapter, the VIC, and splitting it up into multiple logical adapters and passing those through, say, an ESX as a direct path IO, something like that. That's adapter FEX. VM FEX goes even one step further and completely bypasses the hypervisor altogether. And the ports are actually dynamically created by the Fabric Interconnects talking to vCenter in the distributed switch, the virtual distributed switch, and actually creating a direct link between the VM and the Fabric Interconnects, and thus bypassing the hypervisor. So, and again, this is a little bit of a breakdown for you. You kind of see adapter FEX kind of virtualizes, you know, this first level right here, virtualizes through there, and VM FEX actually just completely bypasses the hypervisor altogether. So it's completely independent. It's Cisco's recommended highest performance mode. They suggest even maybe a 30% increase in performance, as well as a corresponding decrease in CPU cycles on the host, because who's processing all that Ethernet traffic? Well, the host is. So that's a little bit about VM FEX. I'll be honest with you, I don't have a lot of customers using it, but I do definitely see the use cases for it. And it is pretty slick once you've worked with it a little bit. You know, it just really depends on whether or not you feel like you need that level of you know, another added level of complexity to your environment. You can, by the way, associate up to 8 vCenters with Cisco UCS UCS Manager. So you don't just have to have one vCenter. So you can have up to 8, and you can apply those VM FEX policies dynamically across all 8 of those. So it's good if you do have separate environments for test and dev and stuff like that. It does really work well.
So we have a question then about adapter FEX creating a dedicated FC port to an FC tape drive for instance. And I think it's important to clear up, you know, what FEX is really for. So can you answer that question?
Yeah, the FEX is the adapter FEX and even the VM FEX. This is going to be completely internal. You're not going to see a physical port connected for a tape drive on something like that. If you're going to do that, 9 times out of 10, you're probably going to configure the Fabric Interconnect itself to have a storage appliance port. That's the most common use, by the way, is for tape libraries of those things, unless you're going to do a direct attach SAN kind of scenario. But typically, I guess the use case would be if you wanted to present a virtual fiber port and pass it through to your VM because your VM was doing your backups and it needed to see the fiber channel port itself. for some reason, but I don't think that's what you're talking about. I could be wrong. Am I making myself clear, Trevor?
Yeah, you are, but I just wanted to make a clear distinction because sometimes this comes up. FEX is really for Ethernet traffic only, so your fiber channel traffic is not going to be traversing a FEX link. What you could do maybe is investigate like a vSAN, and I'm not talking about VMware vSAN. I'm talking about UCS's notion of having a bunch of virtual SAN topologies, and we don't have time to get into that. But that's something that you might want to pin to a specific port and look that up maybe on a future topic on Cisco technologies. We can cover that in more detail.
Yeah, good point.
Okay, so he was talking about backup exec on, I guess, talking directly to a tape drive. And
so in that case, you wouldn't use VMFX at all. You would provision another virtual HBA, okay? Because as Trevor mentioned, this is Ethernet only. You provision a virtual HBA, and you would take that virtual HBA, and instead of applying a VHBA policy to it, you would just pass that straight up to the hypervisor and use, like an ESX, use direct path IO to actually pass that PCI device through to the guest VM. Okay?
Okay, that answers the question for now. Thanks,
Ben. Yeah. If I was nearer to the slide of the VHBA template, we could look at that. But remember, you can create, you don't have to create just one or two VNICs or one or two VHBAs. You could have 4 VHBAs if you want for every ESX host. Any use case for creating extra VHBAs is for something like that, for a direct path IO where you need to present virtual PCI devices. So let's finish up here with management and monitoring and kind of go through just some different little things, a couple of little more advanced troubleshooting things that you might look at, but also just some basics. So remember I talked about the admin tab where you would have some different things. Admin is where you set up your management interfaces. Fabric Interconnect, A, B, and the virtual IP. So the virtual IP is actually what you address, and so that's what gives you that single point of management, right? You would connect to UCS Central. So UCS Central is for managing multiple installations, multiple Fabric Interconnect pairs is UCS Central, and allows you to do the same thing that you're doing on a single Fabric Interconnect pair on multiple. It's kind of like a meta UCSM, if you will. Configuring call home is also done there, as well as all of your RBAC stuff. And generating your lovely tech support bundles. If you haven't been in the interface before, one thing that you'll notice is sometimes you'll see a plus sign up here. That plus sign is never to create anything. It's only an expand and contract button. If you're going to be creating or trashing or editing anything, it's going to be on the right bar right here. And sometimes that gets people who are not familiar with the interface. So just click that button, create a download a tech support file, or just create one if you want to. Pretty straightforward. And let's talk about the FSM for a second. So this is a monitoring tool. The FSM is the finite state machine. You would think it would stand for something like Fabric Status Monitor or something like that, but that's not what it is. The CLI is there in blue, show FSM status. The FSM is based on the concept that any action I'm applying to my fabric has a finite number of stages. it moves between stages, and then it finally ends up in a completion of sequential operations. So only one operation is active, configuration operation on any piece at a given time, though there might be a long sequence of actions. So changing a fiber channel port, for example, from a unified port to a fiber channel port, will generate a sequence of actions that will appear in the FSM that can be monitored, and you will see the progress bar go from 10 to 20 to 40 to 48 to 50 to 70 to 100. And you will see all of the sequence steps that will be happening, and if there are any errors along the way, those will be noted, which are really helpful for troubleshooting. So the FSM, it displays for every component. Every component has an FSM tab, and so you can go in and look at that. There's also VMware integration with the vSphere client. The latest version, I think, is 0.9.4, if I remember right. And again, you can register up to 8 vCenter instances, and that will appear in your web client. It works with the web client in the administration section, and you can go in and configure that. You have to just register. You have to make them talk to each other, etc. And then you can see your ESX servers, your non-ESX servers, and everything that's within that UCS domain. And UCS domain is really just everything that's managed by that pair of Fabric interconnects. You can't do a whole lot with it. I imagine that there'll be more integration throughout. I use it more as a monitoring tool, and some customers like it. Some customers are just like, I'll just go into the Fabric Interconnect. It's not a big deal. So it's certainly not as full featured as the actual UCSM. So now when it comes to monitoring your ports, I've gotten a lot of questions about that from customers. How do I monitor my traffic? And what are the different ways to do that? And there's some ways. It's not as nice personally. It's something I would like to see beefed up a little bit in future revisions to make it a little bit better. But it does have good real-time information, not historical. You can see all of the virtual circuits in the GUI. You can also find them in the CLI if you know the right commands. But you can kind of see where they are, what their status is. You can click on them to navigate over, and that's under VIF, Virtual Interface Paths. Okay? And you can do, when you click on an interface, you can go into statistics, and you can do a chart, that'll give you kind of like a Nexus OS or a iOS list of transmitted, received, etc., or you can view the graph in real time. And you can customize the different components of that graph that are normally available in the CLI. So it can be helpful for minor troubleshooting things, but again, I think it's an area they can improve. Here's a little bit about how you can view VHBA stats. One of the things that you'll want to get in understanding is the southbound facing ports are called host interfaces, and the northbound facing ports are called network interfaces. And I'll show you what that looks like when you run the command. And so you'll notice, this is from the CLI, of course. Show platform software, Woodside, SDS. Woodside is the old term. The new term is Redwood. I have that in the slide deck. But you'll see right here, NI, that's network interface. So this is NIF 0 to 7. And HI, host interface, 0 to 7. And so this is your mapping. And if you want to look at the ports and your port statistics, this is what you have to know. You know, I want to look at network interface 4. I want to look at host interface 10, for example. Sorry, 10 right there. So there's hosts HI10. It's a little hard to read. but that's host interface 10 right there. And you can see it's mapped to blade 6, port 22. Okay? And so once I know that information, I can actually go in and do my full show platform software, Woodside, Armon, 0, HIF7, NIF7, etc. And it's going to give me all of my statistics. You know, and this is very deep. You know, you a lot of times you won't go into this. I use this 9 times out of 10 when I'm using these commands. It's because I think I have a bad twin-X cable, and I want to see if my CRCs are being stomped or not. I want to figure out where that packet corruption is happening. If it's just passing the packet corruption along, or if it's happening in a particular location. Is it the VIC that's bad, or is it the IOM port? Is it the twin-X cable, or is it the Fabric Interconnect port? You know, etc. So this is the kind of thing, you know, I wouldn't expect that you would have to know this level of detail. You certainly do want to know the different spheres of the CLI. So if you want to do connect to the IOM, connect to local management, connect to the chassis, these are the different management shells within Nexus OS, or within UCS. And then the other option, which again I use a lot, is Connect Nexus OS, which allows me to run Nexus OS commands against the Fabric Interconnect and all those ports, which is just really nice. So if I want to do a Connect NX OS, and I can show my stuff, I can show the FEXs, I can show the interfaces, I can show my statistics, I can show my port profiles, etc., which is really nice because I'm familiar with Nexus, right? So,
and it's interesting to note that when you do the Connect NXOS, it's only read-only. You can't, you know, change your ports or anything like that. It's just showing you with a switch view of what your environment looks like. But we do have one question, Dan, and that's about NetFlow support on the Fabric Interconnect. Is there any NetFlow support there?
There is if you put the 1000V in there.
Okay. But for the most part, the only thing that you can do as far as sending to an external device is regular span.
Yes.
Not NetFlow.
Yes. If you use the vSphere 5.5 virtual distributed switch within that, you can use NetFlow in that as well. You know, it might be another way that they'll. If that's a requirement, there's a couple of different ways to do it. I would say most people do it by adding the 1000V. Same thing. So here's another, as you were saying, Trevor, Nexus OS. Doing, you know, again, most of the time you're doing this, you're using it to verify a configuration or to look at something. You can't change anything. Thanks for reminding me about that, Trevor. Reminding me to say that. And you know, I can see my virtual interfaces. I can see all of their communication. I can see virtual interface 946, which I saw in my VIF paths. I can see that that's on the right vSAN, and it's going out this external interface, you know, etc. So, and then one last thing before we close out. Confirming my SAN boot configuration. So this is what SAN boot will look like: Cisco VIC FC or Cisco VIC iSCSI. And then if SAN boot actually installs, you will see the LUN that will be presented right here, and then you will see option ROM installed successfully. If you've configured, as you should, a left and a right Fabric Interconnect force and boot, for example, in an FC environment, you will see this message twice. If you're doing an iSCSI where it's a active standby, then you'll only see it once. And then, again, this is kind of just a little sequence that you can do. Connect to the adapter where this is chassis, server, and the port ID. Tell it to actually connect, attach to the Fabric, and then list out the VNICs, and it'll list you, all the VNICs that are associated, and then you can list the LUNs that are associated to that VNIC. Now, why it's called a VNIC if it's fiber, the syntax to me is a little weird, so I just wrote it down for you because that's just something I had to memorize if I wanted to know it for the exam. So that is all the slides.
Okay, well, I thank you, Dan, for staying with us for the whole hour and a half. And for those who are listening on the recording, thank you for staying with us. A lot of great information about UCS, but don't be scared by the volume of information. If you take it in bite-sized chunks, you'll do well with those exams. But this was great coverage because there were a lot of intricacies that you may not necessarily pick up even if you use UCS day to day. So thank you very much, Dan, for all of that content.
You're welcome.
Okay, so since we have gone a little bit longer than normal, we're not going to open up the lines for live chat right now. So come back next week for part 2 of the CCNP data center presentations. And if you have any leftover questions, we'll try to address them at that time as well. So thank you, everyone, and thank you, Dan.
Sounds good. Thank you, guys.